Welcome back to Investigating Hadoop Logs with LogDelta. Part 2, Visual Analysis of Logs Textual Content. Previously, we focused solely on investigating log file names. Now we'll analyze the actual textual content within the runs. This analysis is specified in the file 2_vis_run_content.yml. To generate the results, execute the command python-m logdelta.config runner-c2_run_content.ml. The output will be saved in the out2 folder. We'll continue by examining the output, starting once again with the simple plot. This plot shows the runs with two axes, the number of log lines on the y-axis and the number of unique terms on the x-axis. When we refer to terms, we mean words or tokens. LogDelta provides several methods for splitting text into terms. Since the y-axis remains the same as in the previous analysis, we can reuse the boundary of 3000 log lines to classify a run as anomalous. On the x-axis, we observe that a reasonable boundary for unique terms could be set at 3400 terms. When we zoom inside the box defined by these boundaries, 3000 log lines and 3400 terms, we find all 8 normal cases and only 3 anomalies. In other words, this approach performs slightly better than the previous one, as it can now correctly classify approximately 86% of anomalies, successfully identifying 18 out of 21. On the screen, you can see the results of the two simple plots. One produced in the previous video using just file names, and the one we just analyzed based on textual content. Feel free to pause your video player here to examine the results in detail. Now we turn our attention to the UMAP plot, which is also produced in the previous run. UMAP operates on the document term matrix, where log files are treated as documents and terms are derived based on the word splitting applied during pre-processing. For example, the document term matrix includes the following details. Log file 1 contains the term IP 2 times, the term address 4 times, and the term is 3 times. Log file 2 does not contain the term IP, but the term address appears 3 times, and the term is appears 5 times. Log file 3 contains the term IP once, does not include the term address, and has the term is 9 times. On the screen, we have 3 different UMAP visualizations generated by executing the script 3 times. UMAP visualizations will vary between executions because compressing multidimensional space into 2-dimensional space depends on a random seed that changes with each run. This variability makes it important to perform multiple runs and compare the outputs to evaluate how repeatable the observed patterns are. We can also apply the boxing strategy here, where we use the boundaries on the y and x-axis of the normal cases to draw a box. Everything inside the box is classified as normal, while anything outside is considered anomalous. On the first UMAP, we can see the drawn box on the screen. Within this box there are 10 items, of which only 2 are anomalies. Moving on to the second UMAP, applying the boxing strategy shows 3 anomalies inside the box, which still manages to cover all 8 normal cases. This result is consistent with the previous result we got using simple map. Finally, in the third UMAP, the box again captures all the normal cases and includes only 2 anomalies. As shown on screen, it appears that the boxing strategy applied to UMAP is slightly better than using boxing strategy on simple plots. However, at this point I'm starting to grow suspicious of the run. Machine down application 1445062781478_0020. In UMAP1 it appears inside the box of normal points. Note that on the screen I've zoomed into the boxes for better visibility. In UMAP2 we see that this run is just outside the box boundary. Meanwhile in UMAP3 it is back inside the box. Looking at the previous plots, we notice some inconsistency as well. In the simple plot with textual content, the run is inside the box. However, in the simple plot with file names, it is outside the box. To summarize, the high-level visualization approach using boxes seems to yield fairly good results. However, we have some questions regarding the correctness of the labels. That said, we cannot make such decisions solely based on these high-level plots. We will proceed with more detailed analysis in the next videos to investigate further.